Hi, I am Sanjay Patel. In today's lecture, we are going to derive the equation of right circular cylinder. First of all, let us understand what is right circular cylinder. According to the concept of cylinder, it must have an axis and one generated line. So I am taking an axis of the cylinder as this straight line. Okay, suppose this is a fixed line which is the axis of the cylinder. Okay, and we take another line which is a variable line, and it is which is parallel to this line small l. Capital L. Let us take a line somewhere here. Okay, fine. So this is my variable line. Now what I want is, I want distance between these two. When I rotate this small l, I revolve this line small l about the line capital L in space, and then for all the position of the line small l, the distance between this variable line and this fixed line must remain the same thing, that is constant. So this is our variable line, and this is fixed line. Okay, this is fixed line. So the distance between these two, that is this distance, say this must remain constant. So this distance must remain same. So if you rotate this way, the surface generated by this revolution in 3 dimension about this fixed line is called a right circular cylinder. So what is a right circular cylinder? Given a fixed line and just a minute. Given a fixed line capital L and a variable line small l, if you revolve this line small l about the fixed line in space in such a way that the distance between the two lines remains constant, then the surface generated by this revolution is called a right circular cylinder. Okay, so the base of the right circular cylinder is a circle. Okay, so I can have a circle over here. To understand more clearly, let me keep it over here also. So this kind of cylinder, which is known to you from the school. Now we are going to obtain the equation of this cylinder. Okay. Here the fixed distance, the constant distance is called radius of the cylinder, and that we are denoting by small r. This is axis of the cylinder, and this is radius of the cylinder. This is radius of the right circular cylinder. So let me write down the definition. Definition of right circular cylinder. The surface generated by revolving a line small l about a fixed line capital L in the space, that is in R3, in such a way that the distance between the two lines, distance between the two lines, that is the variable line small l and the fixed line capital L, remains constant or same, is known as, this surface which is generated is known as right circular cylinder. It is known as right circular cylinder. And we are going to obtain the equation of the right circular cylinder. Okay, so let me write down precisely what is the equation of a right circular cylinder. It is also very, very important. So prove that the equation of a right circular cylinder having radius small r and the axis is the straight line, x minus alpha upon L is equal to y minus beta upon n is equal to z minus gamma upon n, is given by the equation. You can remember this equation easily. I am giving you a special form: x minus alpha comma y minus beta comma z minus gamma. This is the cross product of the two vectors as written here, and then taking the magnitude square, this is equal to r square into L square plus m square plus n square. Okay, and one can simplify also, and that we'll see the simplification later on. So let us obtain this equation, and for the derivation of this equation, first of all you must draw the same figure what I have shown you. So let me copy this figure again. So let us prove here and put this equation. Okay. Now so this is a right circular cylinder. The axis equation is given by x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n, and the radius of the cylinder is small r. So these two things are given, and we want to obtain the equation of such a right circular cylinder. So what I do is I take any point on this cylinder. So let me write here only, so that will be easy for me. So take an arbitrary point on this cylinder, say here, let us call it P, whose coordinates are x, y and z. So P, x, y, z is any point on this cylinder, and we draw a perpendicular from P onto the axis of the cylinder. Okay, and suppose m is a foot of the perpendicular. This axis is passing through the point alpha beta gamma, so that alpha beta gamma point is somewhere on this line capital L. So let me take that point say here, and let me name it as A whose coordinates are alpha, beta and gamma. Okay. And remember this point, if it is here, then the foot of the perpendicular will be same as A. But at the moment, I am assuming that M is different from A. And later on, you can check that the equation will satisfy this case also. Okay. Now let us join this A and P and complete this triangle. Okay. Fine. So let us consider this triangle AMP, which is obviously a right angle triangle. Okay. And let us assume that the angle PAM is theta temporarily. That is, okay. So let us start the proof this way. Let Px, y, z be any point on the right circular cylinder. On the right circular cylinder. Okay. Then we draw PM perpendicular to the axis of the cylinder. Okay. Draw PM perpendicular to the axis of the cylinder. Remember that the axis L is passing through the point capital A, alpha, beta and gamma. That we have mentioned in this figure. The axis is passing the point A, alpha, beta, gamma. Okay. So therefore we can say, therefore the triangle PMA is a right angled triangle. Okay. Now in this right angle triangle, what I will do is I will evaluate the angle theta. Let us suppose that angle PAM is theta. Suppose the measure angle PAM is equal to theta. And here I am assuming that this A is not equal to M. Remember. Okay, so that we have a triangle in this case. And we are going to find the value of theta in two ways. The first simple way is from the triangle, say PMA, I can find the value of sine theta is equal to opposite of theta, opposite side of the angle theta, that is PM, upon the hypotenuse, that is AP. So I can write here, it is PM upon AP. Okay, let me call this as result number 1. Now in this figure we can understand that this vector AP, whose endpoints are alpha, beta, gamma and x, y, z, this vector AP can be given by, say x minus alpha, y minus beta and z minus gamma. So this is the vector AP. and let me call this vector as x bar. Okay, and the angle theta is the angle between the vector AP and the line L. So the direction of the line L I can take as the second vector, which I would like to say denote in this manner. So this vector, let me use this vector, say I'm calling this vector to be y bar, and it is nothing but same as the direction LMN of this axis. So theta is also the angle between these two vectors x bar and y bar. So I will find the value of theta using these two vectors, using your vector geometry. So let me write, and now the vector AP, the vector AP is given by, directly, the vector AP is given by x minus alpha, y minus beta, and z minus gamma. And let us call this as x bar. Okay. Also, the direction of the line L, the direction of the line, that is axis of the axis, is say y bar, is equal to L comma M comma N. Okay. Then the angle theta between the two vectors x bar and y bar, therefore the angle theta, which is the angle between the two vectors x bar and y bar, okay, this is given by the sine formula I want to use here, because I want to compare this value with the result number 1, is given by sine theta is equal to mod of x bar cross y bar upon mod of x bar into mod of y bar. Okay, so that is, you will get sine theta is equal to, what is x bar? X bar is the vector AP, so I am writing AP here, AP cross y bar, which is just keeping y bar as it is, and denominator is again x bar is mod of AP into mod of y bar. Let me call this as equation number 2. So what I have done, the basic idea is I have found the value of sine theta for this angle PAN in two ways. One is given by this equation, sine theta is equal to PM upon AP, okay, and the other is given by this. So comparing equations 1 and 2, comparing equations 1 and 2, we get the sine theta was AP upon PM in that first equation. So I'm writing, sorry, PM upon AP, it was PM upon AP. Let me show you again. It is opposite of theta, that is PM upon AP. Okay. And the second form, the second equation is mod of AP cross y bar upon mod of AP into mod of y bar. Okay. So this and this will be cancelled. And what is PM? PM is nothing but R, that is radius of the cylinder. Radius of the cylinder. You can see again in the figure to understand. This PM is the radius of the cylinder. So putting the value of PM is equal to R in this, we get R is equal to AP cross y bar upon only mod of y bar. Okay. Now substitute the value of these vectors. So R is equal to AP. What is the vector AP? It is x minus alpha, comma y minus beta, comma z minus gamma, cross y bar, which is nothing but L, comma m, comma n, upon mod of y bar, that is again L, m, and n. Okay. So this is the required equation of a right circular cylinder. You see, we obtain the same equation. Yes, you can square on both the sides and write down this simplified form. Let me write this way. Squaring both the sides, I can write this as x minus alpha, comma y minus beta, comma z minus gamma, cross L, comma m, comma n whole square is equal to R square into L square plus m square plus n square. Okay. What we have done is this thing, squaring both the sides. Squaring both the sides. And also we have used that mod of L, m, n, is nothing but square root of L square plus m square plus n square. And so its square is simply L square plus m square plus n square. This is the required equation of a right circular cylinder. We can still simplify this by expanding this cross product. This is x1, x2, x3, and this is y1, y2, y3. Its cross product is again a vector, say z1, z2, z3, and its magnitude square, this is modulus, remember. This is not bracket, it is a modulus sign. So this is a modulus. So this square is nothing but z1 square plus z2 square plus z3 square. So first of all, let us simplify this. We can write this equation also in the form, you know how to find the cross product of these two vectors. So we first hide these two terms, so this and this, and take the determinant of this. So what I will get, I am writing directly, or let me explain one few things. So let us call this as, let me write directly, this is equal to the first coordinate square L, sorry, it is not L. What I will get is, let me write L, M, and N over here. So hiding this, we can take the determinant of y minus beta, z minus gamma, m and n. That gives me n into y minus beta minus m into z minus gamma, this square, plus adding this n into x minus alpha minus L into z minus gamma, this square, okay, plus hiding these terms and taking the determinant of these four numbers, we get m into x minus alpha minus L into y minus beta whole square. This is equal to the right hand side as it is, r square into L square plus M square plus N square. Okay, and this is the required equation, which is the required equation of the right circular cylinder. The right circular cylinder. Okay, so in practice, just remember this equation, because this expansion, the second equation, is a very complicated one. It is not easy to remember. So it is better that instead of remembering this equation, you can remember the equation given in star for solving the problems. Okay, it is very easy. Again, if the axis is passing through the origin, what you will get as a special case of this equation that I am writing as a corollary number 1, if the axis of the cylinder is passing through origin, or is of the form x upon L is equal to y upon m and z upon n, then the equation of the right circular cylinder is obtained by just putting alpha, beta, gamma 0 in these equations. So what we'll get is, putting alpha, beta, gamma 0, we get n y minus mz whole square plus nx minus lz whole square plus mx minus ly whole square is equal to r square into L square plus m square plus n square. Okay. Further, if the axis, let me write some more easy case. If the axis of the right circular cylinder is the x-axis, okay, in this case we have L, M and N, that is the direction of the axis, as 1, 0, 0, and x-axis is passing through the origin, so the point on the axis you can take as 0, 0, 0, alpha, beta, gamma. So if the axis of the right circular cylinder is the x-axis, then its equation is, by putting say LMN 1, 1, 0, 0 respectively in this equation, this will go, only L term remains, so this term and this term remains here in the left hand side, so we'll get z square plus y square is equal to r square. Z square plus y square is equal to, here it is 1, 0, 0, so 1 square plus 0 square plus 0 square, like that. And the same way you can write down the other two corollaries which follows from this equation, that equation of the right circular cylinder whose axis is z-axis, is given by x square plus y square is equal to r square, and the equation of the right circular cylinder whose axis is the y-axis is given by x square plus z square is equal to r square. Okay, here z is not present in this equation, means it is arbitrary. Here y is not present in this equation, means it is arbitrary in this equation. So this way we can have some special cases of this general equation of the right circular cylinder. Let us solve some one or two problems based on this equation. So the first example, is this. Find the equation of the right circular cylinder. Find the equation of the right circular cylinder having axis as the line x minus 1 upon 2 is equal to y plus 2 upon 3 is equal to z minus 3 upon 1 and radius, and the radius is 4 units. Okay, fine. So let us find the answer for this. We know the equation of right circular cylinder. We know the equation of the right circular cylinder having axis. You must write this statement first. Having axis x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n, and radius r is given by mod of x minus alpha comma y minus beta comma z minus gamma cross lmn mod square is equal to r square into L square plus m square plus n square. So this equation is the general equation of a right circular cylinder with the given axis and the radius r. In our case, you compare with this equation with the general equation. You will get alpha, beta, gamma. So let me write this way. Say here alpha, beta, gamma, that is the point through which the axis is passing, is 1, minus 2 and 3 from this equation. So I am writing 1, minus 2 and 3. L, M and N are the direction of this axis, which is 2, 3 and 1, and the radius is 4, that is r equal to 4. So putting all these values in this equation star, we get, so from star we get mod of x minus alpha beta gamma, that is x minus 1 comma y plus 2 comma z plus, it is minus 3, z minus gamma equal to 3 only, so it is z minus 3 cross lmn, which is 2 comma 3 comma 1. This square is equal to r square, that is 4 square into L square plus m square plus n square. So this is the answer. Just you have to simplify this properly to get the required, say, result. Okay. So this implies I can write one more step as it is. So x minus 1, y plus 2, z minus 3 cross 2, 3, 1 square is equal to, say here 16 into, this is 4 plus 9 plus 1, so 10 into 4 is again 16. So this is 16 cross say 16, 9 plus 1, 10 plus 4, so, sorry, it is not 16. 9 plus 1 is 10 plus 4 is 14, so 16 into 14, okay. And what is 16 into 14? 16 cents are 160 and 16 fours are, say, 64. So it is 4, 2 and 2. So it is 224. This is equal to 224. Okay, let us call this as equation number 1. What remains is just simplifying this cross product. So first of all, I will find separately this cross product. You can always write it this way: x minus 1, y plus 2, z minus 3, one vector, and the second vector in order you have to write just below this to find the cross product of these two very easily. And when you find the cross product of these two, we again get a vector. So first we hide this thing, we hide this and take the determinant of these two, these four numbers. So this into this minus this into this. So that is 1 into y plus 2 minus 3 into z minus 3. This is the first coordinate. Then for writing the second coordinate, we write minus sign, or we can take in the reverse order. As you know, we keep this fixed. We keep this thing fixed, all the terms below this, and take this into this minus this into this. Or I can take this into this first and then minus this into this. So 2 into z minus 3 minus 1 into x minus 1. Okay, comma. The third thing is keeping this fixed, the third coordinates fixed, and taking the determinant of the remaining terms. So it is 3 times x minus 1, 3 times x minus 1 minus 2 times y plus 2, y plus 2, and this. So this is the vector. This is, you can call x bar, this you can call y bar, and this is your x bar cross y bar. So this is x bar cross y bar. And you want to find the cross product of these two vectors and then take the magnitude of that vector. So magnitude of this x cross y and then squaring it will get directly this thing, y plus 2 minus 3 into z minus 3 whole square plus 4, this square, 2 into z minus 3, or let me write in a nice form, not this way, let me simplify and then write the square. So this is say a, b and c. I can call it a, b and c. This is a, this is b, and this is c. So mod of x bar cross y bar square is a square plus b square plus c square, where a square means simplified form of this, that is y minus 3z, and 2 minus 9, minus plus 9, it is plus 11 square, minus plus 9 and plus 2, 11. Okay, fine. Plus this square. So 2z minus x, this is minus 6, 2 into 3 minus 6, and this is minus plus 1. So plus 7 square plus here 3x minus 2y, and this is 3 into minus 1, that is minus 3, and this is minus 2 into 2 minus 4. So minus 4 minus 3 is minus 7 square. Okay, putting this value in equation 1, we get the required equation. So just this is to be replaced by this equation. So the final answer, therefore the required equation of the cylinder is this thing, y minus 3z plus 11 square plus 2z minus x plus 7 square plus 3x minus y minus 7 square is equal to what was the right hand side here in 1? It is 224. Yes. So final answer is this is equal to 224. Okay. So let us take one more problem at the end. So let me write down the second problem. Say, find the equation of a right circular cylinder passing through the point -1, 2, 1 and the axis whose axis is x upon say +1, sorry, it is x upon +1, y upon -1 is equal to y upon -1 is equal to z upon 2. Okay. We start the solution by writing the equation of right circular cylinder in the standard form or in the usual notation as mod of x minus alpha, y minus beta, z minus gamma cross L, m, n whole square is equal to r square into L square plus m square plus n square. Okay. What is the values of alpha, beta, gamma and L, m, n here? In our problem, alpha, beta, gamma here is the point through which the axis of the cylinder is passing, which is clearly 0, 0, 0. So I am writing alpha, beta, gamma equal to 0, 0, 0. And LMN, that is the direction of the axis, which is 1, -1 and 2, it is here, the denominator. But remember, the radius r is not given. So we'll keep it as it is and substitute these values in equation 1. So we get from equation 1, so 1 implies we get say x minus alpha, that is x minus 0, means simply x, y, z cross LMN, that is 1 -1 2 square is equal to r square into 1 square plus -1 square plus 2 square, which I can rewrite as x, y, z cross 1 -1 2 square is equal to, this is 4 plus 1 plus 1, so it is 6r square. Let me call this as equation number 2. Okay. Now to find the value of r, we use another condition given in the problem, that the cylinder is passing through this point. The cylinder is passing through the point say 1, -1, 2 and 1. That means this point will satisfy the equation 1 or 2. I can write, since the cylinder is passing through the point -1, 2, 1, we can Substitute x, y, z is equal to minus 1 to 1 in this, and we get minus 1 to 1 cross, this is as it is, square is equal to 6r square. Okay, and then you can find the value of this cross product and then its absolute value. So this implies, I am writing like this, 6r square is equal to, let me write over here 1 minus 1 2, and I will find this vector first. So hiding this, 2 to the 4 plus 1, that is 5. Then hiding this, so 1 plus 2, that is 3, and adding this plus 1 minus 2, that is minus 1 square. So this is the cross product of the two vectors. We get 5 minus 3, 1. So it is 25 plus 9 plus 1. Okay, because that is a square. So 6r square is equal to this. So you will get, say, 6r square is equal to 35. Or you can say r square is equal to 35 by 6. No need to find the square root over here, because in the equation we don't want this way. We can just simply put the value of r square in equation 2, and that's all. So substitute this value, this r square in equation 2, we get what was the equation? X, y, z cross 1 minus 1 2 whole square, x, y, z cross 1 minus 1 2 whole square is equal to, see the equation 2, this, and the right hand side is 6 times r square. So I will directly put the value of r square, that is 6 times 35 by 6. So this 6 gets cancelled. And if you simplify this further, you will get the required equation of the right circular cylinder. So I can write 1 minus 1 2, and then taking the cross product of these two, so we'll get 2y minus plus z square plus this in the reverse order. So 1 means 1 into z, that is z, and 2 into x minus 2x square plus adding these terms. So we get minus x minus y square. Okay, that is the left hand side. This is equal to 35. So this is our final answer. I can write it as x plus y whole square plus 2y plus z square plus, say, 2x minus z whole square is equal to 35. You can write z minus 2x or 2x minus z because square is there. So it is same, which is the required equation. The required equation of the right circular cylinder. So we have understood what is the right circular cylinder, obtain the equation of right circular cylinder, and solve some 1 or 2 problems to understand how to apply this equation.